And when you hit enter, this looks like a text file, but it's really not. It's really a rich editing environment, because when you hit enter to create a new row, it knows that years have year, month, and day, and that dollars have decimal values. And when you get into one of the fields, you can hit a hotkey, and it'll give you code insight just like a Java editor does, because it knows that currency is a number, and it knows that numbers can either be a constant like base rate, or it can be an Excel-like formula. So what NPS lets you do is create external DSLs and a rich editing environment all together at the same time, that you can give your users this way of creating basically configuration and other sorts of stuff directly through interacting with this rich editing environment created in NPS. So for all this DSL stuff, what's the goal? The goal really is nothing more than improved abstraction. This idea of trying to stop repeating context over and over again, because as developers, we're drowning in repetition and repeated context. Get rid of all the repetition and create simpler representations for the abstractions that we deal with all the time. Drier configuration and code with less repetition in it. As I said before, this is evolutionary, not revolutionary. You're not throwing away objects and aspects and generics and all that stuff. What you're doing is using this technique to build simpler abstraction layers on top of them. DSLs take longer to write, but they are better abstractions than DSLs, or rather than better abstractions than XML, because they're actually readable. And one of the questions that always comes up is, well, can these be written by business users? And I don't think that's the goal at all. But this is related to the COBOL inference. That most technologies that are supposed to eliminate professional programmers do nothing of the sort. When COBOL came out, they said, finally, we can get rid of these annoying developers and just let the business people write the code directly. And you can see what happened from that. It actually created more work for us. It's also related to this idea of polyglot programming, leveraging existing platforms with languages suited to particular problems, which kind of goes back to what Ted was talking about this morning, why languages are becoming an interesting thing in the Java world right now. And one of my colleagues is a guy named Ola Benny, and he has defined what he views as this new software stack. Excuse me. We have a stable layer written in a language like Java or Scala, a dynamic layer that lets you get things done faster in Groovy or JRuby or something like that, and then a domain layer written in DSLs. And so the stack may look like Java on the bottom and Ruby in the middle and DSLs on the top. There's nothing that says that you couldn't have Scala on the bottom and Clojure and JavaScript in the middle and DSLs on top of that. So the real question is it time for enlightenment to help us through this language, this framework renaissance that we're living through right now? This is a huge advantage if users can read what we produce as developers. Domain-specific languages improve abstractions by eliminating noise and effort in our code, which is why I refer to this as a neoclassical idea, just like neoclassical art used the ideas from centuries past and produced better versions of it using more modern tools. It's exactly the same thing we're seeing in the development world right now in its use of DSLs. That's it. Thanks for listening, and enjoy the rest of the conference.